All right, welcome to the new unit of chemistry. The most important thing you need to know, first of all, is how to pronounce this word, okay? It's kind of a big one, so let's give you guys a little bit of help. Here's a little pronunciation guide. So we say it like stoichiometry. Some people pronounce it stoichiometry, and we still accept those people as okay, but I prefer to pronounce it as stoichiometry. So stoichiometry, that's what we're covering. That is the new unit of study, and you're going to learn a lot of new things. I'm excited. You should have your notes already. If you do not have your notes, you'll want to grab them. Same as last time, you get a whole stack of papers, and you will come back together. Well, you'll put them together, and then you have all your notes just all together. So it's great. Okay, let's have you guys, if you haven't put your name hour, make sure that's on there. And I'm going to have you guys turn to page 1. Page 1. All righty. So the first thing we need to talk about is what a mole is. Okay, maybe you have heard of the little creatures that crawl in the ground, right? These little moles, these guys, they can be kind of cute, but also scary. This is them looking at you face to face. I just think these nails, they're just like the thing that nightmares are made of. Yeah, they dig in the ground crazy. Maybe you have, when you think of mole, you think, oh, those fun little bumps that kind of grow on your skin. Sometimes you get them as like a birthmark and you're like, oh, look at this fun mole I have. Or sometimes they're scary, so you get them cut off. Okay, so those are moles, yes. But the mole that we're going to talk about today is different. So I have a question for you. Would you rather say a dozen eggs or 12 eggs? Would you rather say 4 dozen cupcakes or 48 cupcakes? Would you rather say 12 dozen hamburgers or 144 hamburgers? So a dozen is just a quantity that means 12, right? Dozen means 12. I hope that's already common knowledge. Now, saying 1 dozen versus saying 12 really isn't a huge difference, but when you start to get to really big numbers, right? 12 dozen, that might be a little easier than saying 144, right? And so a dozen is a word we use to represent a number, okay? Dozen represents 12, all right? So if I have 1 dozen, I have 12. If I have 4 dozen, I have 48. If I have 12 dozen, I have 144. The mole is kind of like chemistry's version of a dozen. So a mole of something is a number of something. So much like we say 1 dozen eggs, that gives you 12 eggs. If I had a mole of eggs, I would have this many eggs, and that's a lot. A mole is this quantity, and all of those zeros are correct. Now, this is terrible, right? We don't like the big number, so we write it in scientific notation, right? 6.022 times 10 to the 23rd power. That is a mole. So if you have a mole of eggs, you have this many eggs. That's a whole lot. All right. I want to talk about how big this number really is, because this is such a massive number, we can't even really comprehend it. And so I'm going to give you guys a few examples to show how crazy huge this number is. Okay, the first one, let's say that we had a mole of pennies, meaning we had this many pennies, this many. Okay, so the question is how much money would that be? Okay, how big is that? So maybe you're thinking in your head. Think in your head for a second, how much money would that be if you had a mole of pennies? Okay, I'll give you a second to think. And I'll spoil it for you. If you had a mole of pennies, 1 mole of pennies shared equally between all people in the world would give everyone $1 million per hour to spend for the rest of their lives. So that's a really big number. Not only would you get $1 million every single hour, you would get $1 million, and we'd have some crazy inflation going on. Another example of how big is a mole. Okay, let's say we had a mole of regular old marshmallows. These are regular. These aren't mini marshmallows, regular marshmallows, the ones that are like, you know, the size of a cotton ball. Okay, if we had a mole of marshmallows, I want you to think for a second, How much of the Earth's surface would that cover? Okay, so think of the Earth, maybe what you know about the Earth's size. How much of the Earth do you think that could cover? I'll let you think for a second. So if you had a mole of these regular marshmallows, it would cover the Earth in a layer 12 miles thick. Now, to give you a sense of how big that is, from the surface of the Earth to the top of Mount Everest is 5.5 miles. 12 miles is more than double that, right? That's up to that. There's like this space elevator people are thinking about potentially having as a thing. That's really freaking tall, really tall. That's covering the entire Earth in that, up to 12 miles. Okay, here's another one. This one is crazy. Let's say you had a mole of dollar bills. Okay, dollar bills. And what you're going to do with these is you're going to stack them flat. So you put one flat, stack it. Next one, next one, next one, next one, next one. So our question is, how big would this stack be? If we had a mole of dollar bills and we were stacking them on top of each other, the question is, how tall would that stack of dollar bills reach? At what height? So think for a second, maybe make a guess in your head or tell your table partner. Okay, one mole of dollar bills stacked on top of each other could reach a distance from the sun to Pluto and back, not just from the sun to Pluto, but back. Now, sun, Pluto, back more than 7 million times. That is a massive amount. I actually had to prove this and go in and do the math and figure out the thickness of a dollar bill. And indeed, it is slightly more than 7 million times. So crazy. Moles are huge. Okay, here's your next question. Let's say you had a mole of water molecules, right? Here's our little molecule of water. It's got an oxygen with 2 hydrogens. Let's say you had a mole of water. Okay, the question is, how much volume would that mole take up? You had a mole of water, meaning that you had a mole 6.022 times 10 to the 23rd water molecules. Think of the volume that might take up. And let's see how close you were. So a mole of water takes up about 18 milliliters. 18 milliliters. That's about the volume of a shot glass. So pretty small volume, but that has 6.022 times 10 to the 23rd water molecules present. That just goes to show you how small an individual molecule of water is. Okay, so chemists use moles not because everything they're dealing with is so big, but because everything they're dealing with is so small. And now you guys get this dumb joke. Hooray for the courtesy laughs, hopefully. I don't know, I'm not here today. Okay, so again, the mole is how we deal with really big numbers for really small things, okay? Alrighty, and it's kind of just like a dozen. It's like the chemist's version of a dozen, okay? So we're gonna be able to use the mole as something to help us kind of get some numbers and some amounts of stuff. So this is what we call Avogadro's number. Okay, Avogadro's number is 6.022 times 10 to the 23rd. Okay. All right. And that is equal to 1 mole. If I say 1 mole, I mean this many things. Okay. And I've got some more dumb little chemistry memes that now you get. And it's just more dumbness. Okay. So let's go down and talk about molar mass. Okay. Molar mass is defined as exactly what it sounds like, the mass of 1 mole. Okay. So molar mass is the mass of 1 mole of a pure substance. Okay. Because it's mass, our units are going to be grams. Okay. All right, so let's say that we had a mole of hydrogen, okay? Let's say that we had, let's see, I'll draw it out. Let's say you counted out a lot of hydrogen atoms, right? And they're just there, they're little hydrogens. Let's say you counted those out until you counted 6.022 times 10 to the 23rd atoms of hydrogen. That would be so many. That would take you so long. But let's just say you could do it. Now you took all those hydrogens, you put them in a bucket, and then you put the bucket on top of a scale. And I'm just going to draw a box and write scale. If you took 6.022 times 10 to the 23rd hydrogen atoms, you put them on a scale, and you wanted to see what that scale read, what was the reading? It would read 1.0078 grams. So we can actually use the periodic table to help us find molar mass, which is really awesome and super helpful for us. So 1 mole of hydrogen, which is 6.022 times 10 to the 23rd atoms, 1 mole of hydrogen has a mass of 1.0078 grams. Okay. Now you've already talked about AMU. We talked about that in chemistry A, how AMU means atomic mass unit. So if you have an atom, it has a mass of 12 atomic mass units. But if you have a mole of carbon, it has a mass of 12 grams of carbon. Okay, so the mass of an atom or molecule in AMU is equal to the mass of 1 mole of that same substance in grams. So anytime you look at the periodic table, the molar mass is this number right here. This number tells you if you have 1 mole of aluminum and you put it on a scale and you took the mass of that aluminum, 1 mole of aluminum, which is Al, it would read 26.982 grams. Okay. Similarly, let's say you had neon and you took a mole of neon and you put a mole of neon on a scale and you were to see what the mass was. Its mass for 1 mole of neon would be 20.180, and that's in grams. Gold, if you had the molar mass, if you were asked, what is the molar mass of gold? What is the mass of 1 mole of gold? You would say, oh, it's right here. It's 196.967 grams. Okay, we can find molar mass on the periodic table. Okay, so you guys have this little blurb in your notes. This number right here is your average atomic mass in AMU, but it's also the molar mass. So if we had 1 mole of oxygen, its molar mass would be 15.99 grams. Okay. It's important you guys can find these, right? You find, let's find, which ones are these? Rubidiums right here and neons right there. Okay, find the molar mass of rubidium on your periodic table, tell your table partner. Find it for neon, tell your table partner. You got like 20 seconds tops. Okay, if you found it for rubidium, rubidium's molar mass is about, what is it, 85.46. Okay, so rubidium's right here, its molar mass 85.46. Neon, we just saw 20.180 grams. Alrighty, what I'd like you to do is down at the bottom, letters A, B, C, and D, you're finding the mass of 1 mole. So for each of those elements, just find its mass on the little tile and check with your table partner. Go ahead, write those down. Give you guys just about a minute to do this tops. Alrighty, okay, we're gonna move on. So we care about molar mass because we can use it to help us find other numbers. Let's go ahead and head over to the top of page 2. Okay, top of page 2. So before we talk about how to answer these questions, let's just turn this into something maybe a little easier to grasp. So here's the story. You love puppies, and you obtain 12 equally cute, identical puppies. Without weighing every single individual puppy, how would you find the total mass of the group? And you can't weigh every single puppy. You can't weigh the whole group. What would you do? Tell your table, what would you do? Without weighing every single individual puppy, without weighing the whole group, how could you find the total mass of the group? So what you could do is if they're all identical, you take one puppy, you get the mass of one puppy, and then you say, well, it's got 12 identical things of itself. And so if you just took the mass of one puppy and you times it by 12, you could get the mass of the whole group. Okay, now let's turn it into chemistry for a second. Let's say that you love calcium and you get 12 moles of calcium. Okay, now how would you predict the mass of this calcium without weighing the whole thing? So you can't put it on the scale, but someone tells you, hey, this is 12 moles. Talk to your table partner. What would you do to figure out the mass of those 12 moles? Chat it out. Okay, so if we know that this is 12 moles in here, well, down here, this number under calcium, that's the molar mass. That's the mass of 1 mole. So if we wanted to figure it out for 12 moles, you just take 40.078 and you'd multiply that by 12, and that can give you the mass for that whole quantity of calcium that you got. All righty, so top of page 2. Let's figure this out. So we're going to do something called the fence method. It is crucial that you do the fence method. I know some of you will be able to do this in your head. You'll be able to just type it in a calculator and go for it. I need you to do it the way I'm showing you because it's going to help save a lot of heartache later. Okay, so the first thing we do with the fence method is we are going to start by writing down what we're given. So the number that we're given is 3.5. And we have to include the units, moles of copper. So go ahead and write this down. You're going to write down 3.5 moles of Cu. Okay. Now I'm going to make a little fence. So make a little line. Okay, put a line down the middle, just like that. Now, the first thing I have to do is take these units and copy them down here. So I'm going to copy down mole of Cu. Up top, right here in this spot, I'm putting what I'm trying to find. What is the question asking me? This question is asking, what is the mass in grams of this? So we're trying to find the mass, grams of copper. Okay. So what we plug into these spots, we have to plug in 2 numbers. We have to plug in a number here. We have to plug in a number here. Okay. If you look at your periodic table, and you find copper, you're going to see that copper, 1 mole of copper is equal to, what is it? About 63.54. Pretty sure. Got a few different periodic tables right next to me. Yep, 63.546 grams. All right, so what I'm going to do is I'm going to plug this number in and I'm going to plug this number in. Okay, now pay attention to the units that are with each number. So the 1 is with moles. So I'm going to put the 1 right here with the moles. And the 63.546 is with the grams. So I'm going to put 63.546. Whoops, let's see. Okay, here we go. All right, now we got to figure out what to do with these numbers. So here's the rule. With the fence, I'm going to change colors to make this a little more obvious. With the fence, anything across from each other, we're going to multiply. So we're going to treat this vertical line as if it were just a multiplication sign. And anything that is top to bottom with this line, so we're going to treat this horizontal line as a division sign. So the math I'm going to plug in, I'm going to do 3.5 times 63.546. And I'll divide that by 1. Okay. And so when you go ahead and plug that in, you're going to get 127.9. And here's the thing with this fence. Let me show you. Anything top and bottom that's the same cancels out. So the moles of copper on the top and the moles of copper on the bottom cancel out. Grams of copper is the unit that I'm left with. So that's my unit for my answer. So when it says what is the mass, it's 127.9 grams of copper. And that's my answer. Okay, let's do the next one. Okay, what is the mass in grams of 2.25 moles of iron? We're going to set this one up very similar. So we have what we're given, we write first 2.25 moles of Fe. Okay, and we are, okay, still right here. All right, so we write down what we're given, the 2.25 moles of iron, and then the units we're going to copy down to the space diagonal on the bottom. So right here, we're going to write moles of iron, Fe. Now the question is asking us to find the mass. So mass is grams, so we're going to put grams of Fe right there. Now we just need to fill in the numbers that go in these spots. So we're going to look at our periodic table. We're going to find iron. And if you look at your periodic table, iron is number 26. 1 mole of iron has a mass of 55.845 grams. Okay, now we just need to plug these numbers in. The 1 is with moles, so we put the 1 right here. The 55.845 is with grams, so we put that number up there. Okay, and if I go ahead and multiply across, so remember, these vertical lines are like multiplication symbols, so we're going to multiply across, and then we'll divide by what's on the bottom. So when I plug it into my calculator, I'll do 2.25 times 55.845. Oh goodness, I'm running out of space. Let me just try that again. That was terrible. Try one more time. So 2.25 times 55.845, and that's going to be just divided by 1. When we plug that in, I got 125.65 grams. Okay, make sure you include the grams. We know it's grams because moles on top and bottom cancels out. So grams of Fe is what I'm left with. Okay, so if someone gave you 2.25 moles of iron, you could say, hey, guess what? I know what the mass of that is supposed to be. And you're going to feel super duper awesome and smart. All right, now let's say, let's go back to the puppies. Let's say you still love the puppies. And this time someone gives you a bucket of puppies. And they say, hey, here's a bucket of puppies. And the mass of all these puppies is this number. They tell you the number and the puppies are identical, right? They're all the same. So how would you predict the mass of each individual puppy? If you know the mass of the whole group, what would you do? Tell your table partner. Think to yourself, think to yourself. Okay, so if I was gifted a bucket of puppies, I would think this is adorable and so cute. And how am I going to take care of all of these? But also I would think, I wonder what the mass of each puppy is. So what I would do is I would count and say, okay, how many puppies do we have? Count them up. And if you do the total mass of the group divided by the total number of puppies, that can give you the mass for just one puppy. We're going to do the same thing with chemistry and with moles and stuff. So we just did puppies to help you kind of sort of get excited about doing all this math. Okay, this one's going to look a little different than the previous ones we did. So this is asking how many moles of calcium are in 5.00 grams of calcium. So we start with what we're given, 5.00 grams of Ca. Okay, Ca is for calcium. Make my little line, add my fence. I'm going to copy the units, grams of calcium, right there. And it's asking me to find moles of calcium. So I'm going to put moles of calcium in that spot. Okay, now I need to fill out the words or the numbers that go in these spots. So I look at my periodic table, find calcium, and according to the periodic table, 1 mole of calcium has a mass of 40.078 grams. So I have to plug the 1 in and I have to plug the 40.078 in. The 1 is going to go with the moles. The 40.078 is going to go with the grams. Now on this one, with the multiplication division I have to do, I'm going to multiply across. So I do 5 times 1, but then I have to divide by 40.078. So when I plug this into my calculator, you'll do 5.00 times 1, and then you'll divide that by 40.078. Okay. Let's see. The number I'm going to get on that is 0.12 moles. Whoops, I should have actually written this somewhere else, not right there. Okay, equal to 0.12 moles of calcium. We know it's moles because the grams on top and bottom will cancel out and the unit moles of calcium will stay. So there is my answer for number 3. Okay. For just a second, I want you guys to get some practice looking at your periodic table. Okay, if I say 1 mole of aluminum, what is the molar mass of 1 mole of aluminum? Find aluminum on your periodic table. Tell your table partner, what's the molar mass? You said 26.982 grams. You had to say grams. You were correct. Okay, arsenic. Find arsenic. Arsenic has 5 valence electrons, kind of right in the middle of that right side of your periodic table. If you got a mole of arsenic, what would be its molar mass? You said 74.922. You were correct. And you had to say grams, 74.922 grams. Okay, here's a question. Let's say that I asked you to find the molar mass of CO2. The question is, how would we do this? So we have to be able to find molar mass, not just of individual elements, but also of compounds. So we have carbon, we have oxygen. We need to find the molar mass of CO2. So in this case, where we have multiple elements together, you just find the individual molar masses and add them all up. So the molar mass of carbon, you'd find that. Now we have 2 oxygens, so you'd have to do the molar mass of oxygen twice, and then you'd add those all together. Okay. Right here in this spot where it says molar mass of compounds, this is going to help you find the molar mass of these items. So if we go back, let's do CO2 together. So CO2 has 1 carbon. Go ahead and write this right here. Carbon, it's got 1 of them. Oxygen, it has 2 of them. So carbon will be 1 times its molar mass, which is 12.011. Oxygen will be 2 of it because there's 2 oxygens present. 2 times 15.999. So we're going to get these numbers. So we get 12.011 and we get 31.998. Now we have to add these numbers together. And when I add these numbers together, the total number is 44.009 grams. So if I had a mole of carbon dioxide, the mass would be 44.09 grams. And all I did was add up the masses for each of those elements that were present. Okay. So what I would like you guys to do now, we're going to actually skip a few of these. And I really did throw a lot of these in. Okay, I would like you guys to go to 4, 5, and 6. You have the formulas. I want you to find the molar mass of each of these. So we have water, sulfuric acid, calcium phosphate. It gives you the formula. Follow your steps. Okay, they're right here. And I'd like you to find the molar masses of each of these. Probably I'll have you guys pause the video. So please pause the video right here. So then you can replay or push play and then we can go on after you've attempted these. Okay, pause the video. Okay, hopefully that's been enough time for you to work through and find the molar masses of each of these substances. Okay, so first one, what is the molar mass of water? Okay, water has 2 hydrogens, 1 oxygen. Each hydrogen has a mass 1.008. Each oxygen is 15.999. 2 times 1.008 is 2.016. 15.999. Okay, now we need to add these together. When we add those together, whoops, let's see, is 18.015 grams. That's our molar mass for water. If we had a mole of water, it would have a mass of 18.015 grams. Okay, and that's just kind of my maths right there. Okay, let's do the next one. This is sulfuric acid. Okay, H2SO4. So here's our math. We had hydrogen, we had sulfur, we had oxygen. There are 2 hydrogen atoms in this formula. They're right here. We multiply each of them by our molar mass for hydrogen. Okay. We had sulfur, we just had one of those. Sulfur has a mass of 32.1. Then we had oxygen, there's 4 oxygens right up here. 4 times 16 for each oxygen. Okay. And so we'll take these 3 numbers, we add them up, and you get 98.12. So 1 mole of H2SO4 has a mass of 98.12 grams. And if you got like, 98.10 or 98.2, like that's fine. I just make sure it's 98. If you didn't get 98, something bad happened. Okay, last one, CaPO4. All righty. Okay, for this one, we had calcium. There are 3 of them. So we're going to multiply each calcium by 3. So that'll give me 40.1 times 3 gives me 120.3. And then we have our phosphorus. We got 2 of them, and there are 31 grams for each of those. So that's 62. There's a lot of oxygen. We have 4 times 2 is 8. So 8 times 16 is 128. So when you add all those up, the molar mass for calcium is 310.3, and you'd want to add grams to the end of that. Okay, so that's our molar mass. You can find molar mass using the periodic table. Anytime you see the phrase molar mass, you have to think periodic table. Okay, that has the answer. All right, now we can actually use molar mass to help us solve problems. Okay, Let's say someone gave you 3.5 moles of water, for example. They say, hey, here's 3.5 moles of water. And you're like, this is awesome. You know what I'm going to do first? I'm going to find what the mass of that should be, but I don't have a scale. I just have a periodic table because I take it with me everywhere. So here's what you would do. The first thing you're going to do is write down what you're given. 3.5 moles of H2O. Okay, make your little fence. So we're doing the fence again. Okay, we're going to copy the units in this spot. So we'll go mole H2O. And it's asking us to find mass. Well, mass is grams. So we'll put grams of H2O. Now we need to figure out what goes in these spots right here. So we need to find the molar mass of H2O. If we had 1 mole of H2O, we need to figure out how many grams of H2O that would be. Now, we already did this. You guys should have this up for number 4 that you just did. This actually shouldn't be number 4. This should be number 7. Sorry, my numbers are weird. Okay. So you should have already found the molar mass of water. I'll show it again, but H2O has 2 hydrogens with each having 1.008, and it has 1 oxygen with 15.999. So if we multiply those out and add them together, we total out to 18.015. Okay, so now I need to take these numbers and I need to plug them in to the spots up here. So my 1 mole is going to go with the mole. The 1 goes with the mole. The 18.015 grams goes with the grams. 18.015. Okay, now I'm going to change colors. If we have moles of H2O on the top and bottom, they cancel out. So go ahead and cancel those out. And I want you to circle grams of H2O because that's the unit that you will end with. Now we can go ahead and multiply through 3.5 times 18.015, and we'll divide that by 1. So if we have 3.5 times 18.015, that's going to give us 63.1 grams of H2O. So someone says, hey, here's 3.5 moles of water. You can say, I know what mass that should be, 63.1. And if it's not 63.1, you can say, liar, you did not give me the correct amount of water. Okay. All right, let's do the next one. Okay. Same type of problem. Someone decides, hey, I'm going to give you 58.2 grams of sodium hydroxide. And you say, awesome, that's super cool. Let's figure out how many moles that would be. So they say, hey, here's 58.2 grams of NaOH. And you think to yourself, this is the best day ever. I just need to figure out how many moles that is because moles are awesome. So you copy the units, grams, NaOH. We're going to put what we're trying to find. It's saying how many moles of NaOH do we have? Okay, so we have moles. Whoops, I need to keep that over here. Moles of NaOH. All right, and we need to figure out our molar mass for NaOH. So I'm going to figure it out for sodium, for oxygen, for hydrogen, and then I just add all those together. There's just one of each. So sodium's mass is 22.990, oxygen's is 15.999, hydrogen's is 1.008. If I go ahead and add all those together, I get almost 40. I get 39.997 grams, and that is equal to 1 mole of NaOH. So now I got to plug in the numbers. The 1 goes with the mole. The 39.997 goes with the grams. So now what I'm going to do is I'm going to cancel out the units. Top and bottom, grams and grams will cancel out. Okay. And the units that I'm left with is moles of NaOH. So I multiply across and I divide by the bottom. I'm going to do 58.2 times 1, which is just 58.2. And then I'll divide that by 39.997. The number I got on this one is 1.5, and the units are moles of NaOH. So someone gives you that many grams of NaOH, you can say, hey, this is 1.5 moles of NaOH. They're the same thing. All righty, let's do this next one. Okay, we're gonna go 45 grams of hydrogen fluoride, HF, to moles of HF. So I start by writing down what I'm given. 45.0 grams HF. Make my little fence. Copy my units. Grams of HF are my units. Grams, hydrogen fluoride. And it's asking me to find moles of hydrogen fluoride. So I'm going to put moles HF. Okay, now I need to look at my periodic table, find the molar mass of hydrogen fluoride. Hydrogen has a mass of 1.008. Fluorine has a mass of 18.998. So when I add those two together, we're going to get 20.006 grams is equal to 1 mole. So the 1 goes up top, the 20.006 goes on the bottom, and I'll go ahead and cancel my units out, cancel out the grams on top and bottom. Moles of hydrogen fluoride is what I'm left with. So I'll do 45 times 1, and then I'll divide that by 20.006. So 45.0 divided by 20.006. And that's going to end up 2.2 moles HF. All righty. Okay, number 10. It's asking us how many moles of silver phosphate are present in 82.0 grams of silver phosphate. So we've got to start out with what we're given, 82.0 grams Ag3PO4. Make my little fence. And I'm going to copy down grams of Ag3PO4. It's asking me to find moles, so I'm going to put moles. Silver phosphate. All right. Now, this is going to be a little bit more intense because we've got a really kind of bigger formula. I need to find the molar mass of Ag3PO4. So if I have 1 mole of silver phosphate, we want to know how many grams that equals. So we have silver, we have phosphorus, we have oxygen present in this compound. There are 3 silvers. Each silver has a mass of 107.87. We have phosphorus, just one of them, each of those with a mass of 30.974. And we have oxygen. There are 4 of them, and they each have a mass of 15.999. So let's get those numbers and then we'll add them all together. Okay, I got a molar mass after adding all these together equal to 418.58 grams. So 418.58. I need to put the 1 with the moles, so that'll go up here. Put the 418.58 down there. So now I'm going to cancel out units. The grams on top and bottom cancel out. Moles is what I'm left with, so that's the unit for my answer. I'll do 82 times 1, and then I'll divide that by 418. Divided by 418.58. And that'll give me an answer equal to 0.2 moles Ag3PO4. And there we go. Okay. For number 11, if you'd like to pause, probably I'll have you guys pause for a second. And then after a bit of time, we can push play and we can see how you guys did. So if you'd like to pause, go ahead and pause. All right. Okay, it's asking how many grams of potassium chloride are in 3.2 moles of chlorine, of potassium chlorine. So we write down what we're given, 3.2 moles of KCl. Make our little fence. The units that I'm given are the units I copy. So I'm going to copy over moles of KCl. It's asking me to find grams. How many grams? I'm going to put grams of KCl. Now I need to find the molar mass of this substance. Potassium has a molar mass of 39.098. Chlorine has a molar mass of 35.45. So if I add those together, looks like I get 74.548. And that's grams in 1 mole of potassium chloride. So we got to figure out, where does this number go and where does this number go? The 1 goes with moles because it's down here with moles. And the number that I calculated, that's the mass in grams. So I'll put 74.548. And we will go ahead. Okay, so I plug these numbers in. We're going to cancel out our units, moles on the top and bottom. Then I'll do 3.2 times 74.548. And I'll divide that by 1. So in my calculator, 3.2 times 74.548. And that is equal to 238.6 grams of KCl. And there we go. Okay. So we have covered everything on pages 1 and 2. And this is our introduction to stoichiometry.